Hi students, welcome back. This is Algebra 1, Day 2. Today we're going to go through the questions that deal with the multiplication properties of exponents with variables. Alright, let's take a look through here. In question 1, you can see I have x plus 1 inside parentheses here, right? So it's x plus 1 in parentheses to the 4th power times x plus 1 to the 5th power times x plus 1 again to the 6th power. So how do we work this out? We need to apply the multiplicative properties of exponents. So here I have the product of powers. And what I'm actually going to get whenever I have the product of powers is I am just going to sum up all of the exponents. So that's 4 plus 5 plus 6. All right, you'll find that the answer we get is actually going to be 15. Let me write my answer down in the blank right here. It's x plus 1 to the 15th power. And our answer is A. Okay, moving on, we apply the same principle. Again, we are finding the product of powers. So be sure to review your class notes if you're struggling to remember these rules and properties here, right? Same idea again, but this time I have 3y minus 2 to the power of negative 2. And I have 3y minus 2 to the 7th power times 3y minus 2 to the 6th power. Again, I'm just going to find the sum of all of these exponents here. All right. And here, when I actually sum them up, let's put those in the parentheses here, I'll get 11. All right, so it's 3y minus 2 to the 11th power. Clean this up a little bit. Okay, moving forward, we have question 3 right here, where I have 3x squared inside some parentheses, and it's being squared. Okay, so recall that when I have 3x squared, what this really stands for is 3 times x squared, right? And right here, I'm looking for the power of a product. And whenever I do that, I need to make sure I square each and every number or variable that's being multiplied here. So what this really is 3 squared times x squared squared. Now I know that 3 squared is just 3 times 3, right? And that's going to give me 9. Now what about x squared squared? Well, here I'm looking for the power of a power. And recall that whenever I have x squared squared and there's a power inside my parentheses here that's being squared, I just multiply it. Okay, so what I'm going to get right here is x to the power of 2 times 2, just to make it a little clearer. And I'm going to get, I guess I'll write my solution down here. I'm going to get 9x, 2 times 2 is 4. So hence my final answer is 9x to the 4th power. All right, I'm going to move on now to question 4. Again, we apply the same properties. So if this is not too clear, we can try to write out the multiplications of each of these factors here of the term that's in the parentheses. So I have 2 times x squared times y to the 4th power, right? And all of these are being cubed. Okay, I'm going to apply the same properties here where I'm going to cube each and every single one of the factors of this term. So here I'll have 2 cubed times x squared cubed times y to the 4th power cubed. Okay, I think I'll need a little more space down here to write the next line. So let me do that down here. Now 2 cubed, that's 2 times 2 times 2. That's going to give us 8. And here, when I have x squared to the 3rd power, or when it's being cubed, again, we just find the product of the powers, right? Because we're looking at the power of a power rule right here. And it's the same principle with this y to the 4th power. I'm just going to multiply that with 3 in the exponents. You'll see what we end up with. It's 8 and x to the power of, well, 2 times 3 is 6, right? And y to the power of 4 times 3, that's 12. And there we go for our final answer right here. We have 8x to the 6th power, y to the 12th power. Okay, so right here, I'm going to clear my screen and move on to question 5. Okay, this will do. So we've already solved question 4. I'll just rewrite the answer there so it just doesn't look like a blank. It was 8 x to the 6th power and y to the 12th power. Okay, now I'm going to move on to question 5 here. Again, we're looking at a term inside the brackets here, inside the parentheses. So what I really have is going to be negative 3 cubed times a cubed. And this is multiplied by a to the 5th power. Okay, I'm applying the same rule when I'm looking for the power of a product, because technically in a variable, if there's a coefficient and there's a variable, then it's a product, right, of the coefficient and the variable. Okay, negative 3 cubed, we got to remember that's got to be negative 27, so we still get a negative because it's cubed. And then, well, there's just a cubed here. And this is multiplied by a to the 5th power. Okay, one last little step here. Here, I'm looking for the product of powers. So let me rewrite that coefficient. And what we're basically going to get is a to the 3rd power plus 5, right? Or a to the power of 3 plus 5 here. And my final answer is going to be negative 27 a to the 8th power. All right. So let me move a bunch of this stuff up so that I have some space. There we go. Now I'm going to continue with question 6 here. So given that a to the power of x is equal to 6, a to the power of y is equal to 8, then what is the value of ax plus y? So here we have to remember, in order to get ax plus y, which rule are we applying here? Well, it's got to be the product of powers rules, which means ax times a to the power of y, I meant to say a to the power of x here, sorry about that, is equal to a to the power of x plus y. So in order to find a to the power of x plus y, we think about taking ax, a to the power of x, times a to the power of y. That's 6 times 8, right? And well, 6 times 8, that's 48. So right here, my solution is 48. Okay, this is for question 6. All right, moving on then. Here, for question 7, I'm given that a to the power of x is 3, a to the power of y is 5. Then let's try to find the value of a to the power of 2x plus y. Okay, let's think about it here. How do we get a to the power of 2x plus y? Well, we already know from question 6 that we can get a to the power of x plus y by simply multiplying a to the power of x times a to the power of y. Great, but I have an extra 2 right here. So we got to figure out how we can form a equation that includes 2x in the exponent here. Well, remember our power of a power rule, right? If I have a to the power of x and it's being squared, then I multiply 2 into the exponent of a, right? And that's exactly how we get a to the power of 2x. All right, so great. And here I need to multiply as well by a to the power of y. Okay, let me just substitute the values for a to the power of x and a to the power of y. According to question 7, a to the power of x is 3, so this needs to be squared. A to the power of y is 5. And this is going to give me my a to the power of 2x plus y. 3 squared, well, that's 9. And let's think right away about 9 times 5. We're going to get 45. There we go. So our solution for question 7 is 45. Okay, I'm going to move on now to question 8. Let me write my solution down here. Okay, taking a look right here, I think I'll give myself some more space. So I'll write my question 8 here. I have a to the 5th power. Oh, and this is to the power of 4 times a to the 3rd power to the power of 2 minus negative a times a to the 5th power to the power of 5. Okay, we have a lot to go through here, but let's go through it systematically. First of all, whenever we look at an equation, we have to remember what is the order of operations. Here, I'm going to deal with all those exponents first. So I have a to the power of 5, and this is being put to the power of 4 as well. So I have the power of a power right here. That means I'll get a to the power of 5 times 4. Okay. Moving on to the next exponent, it's a to the 3rd power to the power of 2. So it's a to the power of 3 times 2. Again, I multiply what I see up here in the exponents, right? And let me just rewrite the whole equation the same way, so we don't do too many steps at once. All right. So following this, what I'm going to do is to first work out the exponents. So here, this is a to the power of 20 right here times a to the power of 6. All right, again, I don't want to do too many steps at once, but right here, I want to work out a to the power of 5 times 5. That's going to be 25. Okay, perhaps up here, I'm going to change this line a little bit, since I know that I have to apply the power of a power rule. So it's 5 times 5. Okay, what's next? I have some multiplications and a subtraction to work on. I'm going to work on the multiplication first, leftmost multiplication. So here, it's a to the power of 20 times a to the power of 6. Well, that's going to give us a to the power of 20 plus 6, isn't it? Okay, so let me just clear this up so that this looks like a 20. All right. What's next? Well, 20 plus 6, that's going to be 26. And as you can see right here, before I subtract, I should work on this multiplication first. So here, I'm going to keep that minus sign, and let's work on this right here. It's negative a times a to the power of 25. Now, it's worth reminding that whenever I don't see any powers or any exponents above a variable or above a number, the exponent is 1. Right? It's just that we don't write that 1. So what we have right here, as you can imagine, is negative a to the 1st power, or to the power of 1, times a to the power of 25. So here it's 1 plus 25, right? After applying the product of powers rule. Let's close that out. What we basically have is a to the power of 26 minus negative a to the power of 26. All right. So as you can see here, I am subtracting a negative number, which means that it's equivalent to just adding, right? So it's a to the power of 26 plus a to the power of 26. All right, so since I'm running a little low on space, I'm going to erase the workings for the previous question and just try to move everything up a little bit. So I have space to finish up this one little last part of the question. Sorry, let me try to move it up this way. And I'll move this up here. Here, I have two of the same terms being added together. I just add a little coefficient of 2, and I have 2a to the power of 26. All right, we got 2 more questions to go. Let me erase the previous workings right here so that we make space. Let's take a look at question 9. All right, here I see negative x to the 4th power times x squared minus x squared to the power of 3. All right, so here, although we can see that, this is to the 4th power, so I can just write negative x to the 4th power, right? We got to remember that since I have a negative value that's being brought up to the 4th power, since it's an even power, that value now becomes a positive value, right? Just like when you have negative 2 that's being squared, you get a positive 4. Let me rewrite everything else the same way. Minus x squared to the 3rd power. Okay, here we ask ourselves the question that I have x to the 4th power times x to the 2nd power minus x squared to the 3rd power. Which one should I work on first? According to our order of operations, we should work on the exponents first. So let me just leave everything else the same way. And let's work on this as x squared to the 3rd power. Here it's the power of a power rule. So it's going to be x to the power of 2 times 3. And this is going to be 6, right? And up in the front here, you can see x to the power of 4 times x to the power of 2. We have the product of powers. Let's write this as x to the power of 4 plus 2. You'll see that we end up with x to the 6th power minus x to the 6th power. Well, which I think is pretty obvious, should be equal to 0. All right, moving on, I have question 10, our last and final question right here. Let's check it out. Here I have x to the power of 0. Okay, let me write that down. And this is multiplied by y to the 7th power minus 3y to the 7th power. All right, class, whenever I have a number to the power of 0, it's equivalent to 1, no matter what that number is, right? So even though, as you can see here, it's a variable x, it's still equal to 1. Basically, I have 1 times y to the 7th power, which is just going to be y to the 7th power, right? So let me rewrite everything else. As you can see here, I have y to the 7th power minus 3y to the 7th power. Since they are like terms, we're going to combine them. And we just look to the coefficients. Basically, we think about 1 minus 3, and we get minus 2 as the coefficient. And I'll just rewrite the variable part. So final answer is negative 2y to the 7th power. All right. And that's the last question for our day 2. I'll see you on our day 3 questions. Bye now.